shit, no one's recording. That's the question. Is the whiteboard recording? Or is it all of you guys recording? I'm gonna pin myself in. All right. So we left off with the mode of action of hormones, which is one of the questions. So if you don't have that yet, it's on the video. In fact, I made a separate video that just has mode of actions of hormones. So that's under, those are all under pages. So lipid soluble, water soluble. Unfortunately, I want to know the steps. So that's how hormones work. We talked about that. We talked about how hormones interact. We talked about target cells and upregulation and downregulation, which means making more receptors or fewer receptors, depending on how sensitive the cell wants to be. Now we're going to kind of talk about the whole control system. And as I wrote before, it's controlled by the hypothalamus. And so the hypothalamus gets input from different sensors in the body. It just depends on what's going on. The hypothalamus controls a lot of things. It controls hormones, but it also controls things like fear and hunger and thirst. So here we're talking about chemicals. Ultimately, the hypothalamus controls a lot of chemicals that are released by your body. It doesn't do it, it controls it by controlling another gland. So it receives output and it has an output, it releases a chemical in response. And those are releasing hormone. So depending on what the input is, it's getting input from the body saying, this is too high or this is too low. Depending on what it is, it has a releasing hormone that is going to release. That releasing hormone is going to go to the pituitary gland. And if you look at the pituitary gland, it's right next to the hypothalamus, and it's got these two lobes. It's got a anterior lobe and a posterior lobe. So we can divide the pituitary into two lobes, anterior and posterior. Anterior has another name. In fact, the pituitary gland has another name too. Just so in case you see this word. The adrenal gland, we call it the hypophysis, hypophysis. And then the anterior, the other name for it's adenohypophysis, and then there's a posterior, which is called the neurohypophysis. So neuro you've heard of, hypo you've heard of. So the only word that you're going to learn is this word physis. There's nothing special that I'm doing, like, oh, how did he know to write a big word, even though he hasn't lectured this in a long time? Because I'm just taking three smaller words that I can remember and I'm sticking them together. That's all I did. So, yeah, so we're going to talk about these two. When I talk about these two, I'm going to tie this in with it. So this pituitary gland is going to control other glands. So I'm going to talk about the anterior first because it's more complicated. Posterior is easier, so I'll talk about that next. So what I'm going to do is, so what happens is that first I'm going to do the anterior. And in order for a hormone to be released from the anterior pituitary, you first have to, the hypothalamus has to first tell it to do that by releasing one of its hormones. So there's 7, so the anterior pituitary gland has 5 cells which make 7 hormones. You have to first get a releasing hormone. These 7 hormones are going to different places in your body. For example, the mammary glands, or the thyroid, or the adrenal glands, which sit on top of the kidney, or the testes, ovaries. So these 7 hormones are going to different places in the body. It just depends on like what's up, what needs to get released. Oh, and I guess since I'm on that, like before I get on this, we didn't talk about negative feedback and positive feedback, and you probably had it in another class, but most of this hormone, most of what stops this is called negative feedback. So I'm going to give you an example. I'm going to erase this, and then I'm going to give you an example. So 5 cells, those 5 cells, which I'm going to go over, they make 7 different hormones, which I'll go over. And in order for these hormones to be released, there are releasing hormones. I'm going to go over that too. So I'm going to make like a chart. So let me erase this. Let me talk about negative feedback. Or let me talk kind of about how the whole system works. We talked about your thyroid gland. And I don't know why I say we. I was doing all the talking. But I talked about the thyroid gland last class as an example, and it regulates your metabolism. So it keeps your metabolism, normal levels. So if your thyroid gland is not making its hormones, then your metabolism's too low. If it's making too many hormones, your metabolism's too high. So you could think about things that would happen, like what would happen if my metabolism was low. You're tired all the time. You're putting on weight, and we're all like, yeah, that's me, my metabolism's bad. No, but I mean like an extra tired, extra weight, maybe constipation, something like that, right? Because just everything's moving slow. And if you think about your metabolism's too high, losing weight, not being able to sleep, you're just hot all the time, whereas low metabolism, you'd be cold all the time. So our thyroid gland regulates that. And so those hormones, which we're going to learn later, they're called T3 and T4, I guess for short. T3 and thyroxine are T4. But for right now, just those are the 2 hormones that control your metabolism. Well, your hypothalamus is taking in information. There's receptors talking to the hypothalamus because the hypothalamus wants to know, how's metabolism today? Is it good? Is it in level, at the right level? And so there's communication. If it's too, let's say it's too low, right? So this is too low and your metabolism's too low. That means there's a problem. So now the hypothalamus has to try to take care of that problem. It knows there's receptors in your body, like little sensors, that are picking up that your metabolism's low. So the hypothalamus gets notice of that. The hypothalamus now has to try to fix the problem. So the hypothalamus communicates with pituitary gland. How does the hypothalamus communicate? It has a releasing hormone. That's what it does. So it makes a releasing hormone. And the releasing hormones are actually pretty easy, the names of them. They all end in RH for releasing hormone, all of them. They're all going to end in RH. And by the way, and I'm just going to put a T. We can just say thyroid releasing hormone, thyrotropin releasing hormone. But anyway, it's T because ultimately we're talking about the thyroid. It's the thyroid we want to change. So kind of giving you that one already. So TRH, we can use the abbreviations. The abbreviations are encouraged. Oftentimes I'll tell you, I want you to write things out. It's acceptable. It's acceptable to just write the abbreviation. So most of these hormones have abbreviations, like these two. So TRH is released, and that's going to the pituitary. That's the hypothalamus saying to the pituitary, go, something's up with the thyroid. Go talk to the thyroid. I got reports that there's not enough of this. So go talk to the thyroid and tell it to do its job. Now the pituitary gland, it's going to release a hormone that's going to stimulate the thyroid gland. In fact, this hormone is called thyroid stimulating hormone. It's a hormone that stimulates the thyroid. Oh, that feels better. That feels worse. And it goes to the thyroid. And it's like, hey, thyroid, what's up? The boss is on my ass. Go fix it. And so the thyroid, ideally, the thyroid is going to start working harder and making more T3 and T4. So I made it like a circle. And then more T3, T4, you keep making it until it gets the right level. So here's the thing. Here's how negative feedback works. What was the problem? The problem was there wasn't enough T3 and T4. So once we have enough T3 and T4, we're going to break the circle. That's negative feedback. Once the problem's solved, it's done. You don't have to keep. So we break the circle. Once there's enough T3 and T4, the hypothalamus isn't going to hear about it. There is no more TRH. There is no more TSH. You're not making more of it, right? Everything goes back to how it was before. Negative feedback is addressing a negative problem. I'm not giving you the actual definition. I can't even remember what the textbook definition is, but it's addressing a problem like a negative problem. That's how I look at it. So this is an example of how the endocrine system works to keep everything, to keep that balance, right? So, in fact, about 10% of us have low thyroid, and so you can check this, and that's one way to see how is your thyroid. But a more common way is that they actually go to the pituitary gland and they look for this. So if I have low amounts of this, I'm going to expect high amounts of this, right? Because this is compensating for this. Your thyroid's not making enough of this, so your pituitary gland is bombarding it with TSH, like, hey, go make more, go make more. So low T3 and T4, you're going to find a high TSH. And the opposite is true. If your thyroid's making too much of this, your pituitary gland is going to chill out. When everyone's working extra hard on the factory floor, what's middle management doing? Sitting on their computer, watching YouTube videos. So less TSH. No need to talk to the thyroid, it's overworking. So I'm going to find a low level of TSH. That's going to tell me maybe there's too much of this being made. That's a common thing that doctors look for. But anyway, breaking that's negative feedback. A lot of hormones are controlled by negative feedback. Let's solve the problem. Let's stop the problem. I'm going to give you an example of positive feedback. Having a baby. Giving birth. Your body feels it. The baby's starting to come out. You can't be like, no, let's put it back in. That would be negative feedback. Let's just solve the problem. Just stick it back in. No. That's it. It's coming out. So positive feedback is like, okay, well, this baby's coming out. Let's just help it. It's going to happen. Let's throw some more hormones at this to make it come out more smoothly and faster, right? So, there's different hormones that are going to dilate the cervix and contract the uterus. So your body starts throwing more hormones at it. It's going to happen. It's positive. You're having a baby. That's positive. So it's positive feedback. It's going to happen. Just let's get it over with. Let's make it happen. So that'd be positive feedback. And you're not going to see a lot of examples of that. But negative feedback, yes. For example, here, this is negative feedback. Any questions? I even talk louder with the mask on for no reason. It's not blocking my voice. No questions. I'm gonna answer a couple of these questions really quick, even though they're not. Yes, right. Okay, done. Ashley took care of it for me. All right. I know there's 4 people with me. Let's talk about the pituitary hormones. Let's talk about the cells first. There's 5 different cells. They're all going to end in this word troph. The first one, well, since we were on it, thyrotroph. It might be called in your book thyrotropin, but same thing. So thyrotroph. Those thyrotroph cells are going to make thyroid stimulating hormone. 3 letters and I spelled it wrong. I guess I'll put the target here. Why not? So thyrotroph cells, they're going to make TSH, and that TSH is on its way to the thyroid. So that's the cell of the anterior pituitary. That's the hormone that it makes. Next, got a reason for gonadotrope. So something to do with the gonads. So its hormone, it makes two hormones. FSH, follicle stimulating hormone, and you can look it up, it's in the lecture or in the video or your book. And then something called luteinizing hormone, again, that's in your book. The targets are, yes, your privates, but I should be more specific. Testes and or ovaries. FSH goes to ovaries and testes. Both of these hormones work in both males and females. So follicle stimulating hormone, luteinizing hormone. The next one, corticotrope. They're all ending in trope. So gonad, gonado means gonads. Cortical is usually it tips you off that it has something to do with steroids. So think of like hydrocortisone, cortisol, right? So there's that word. So cortical is going to tell you something about steroids, something about the adrenal gland. So the target cell is the adrenal gland. The hormone is called ACTH. Adrenocorticotropin hormone. ACTH, though, we're abbreviating all of these. And there's another one. So ACTH is going to the adrenal glands. The adrenal glands sit on top of your kidneys. MSH is the other one. Melanocyte stimulating hormone. That goes to a gland in your brain called the pineal gland. We don't know a lot about it. I'm probably not going to ask you a lot of questions about the pineal gland. The best research says that melanocyte stimulating hormone goes to the pineal gland, and the pineal gland probably makes, for sure, freckles, but probably something to do with like melanin, like melanocyte, melanin, pigment, and then maybe melatonin, like circadian rhythms, like how you know it's day or night when you're sleeping, but these aren't like conclusive, at least the last time I checked. So those are the two hormones that corticotropes make. All of these, so far we got 5 out of the 7 hormones. They work on negative feedback. That's why I was trying to think, what do I put next? These all work with negative feedback, all 5 of these. The next 2 don't. Lactotrope. So lactation. So the hormone that they make is called PRL, which stands for prolactin. Last one, somato. Somato means growth. SOMATO, somatotrope. that is going to be growth hormone. So stuff that grows, cartilage, bone, muscle, whatever, stuff, liver, it goes to a lot of places. So we got 7 hormones. So you need to memorize the hormones. You need to know what cell made them, where are they going to. It's kind of a pain in the ass, but I mean, some of them like this, you'll kind of learn in not too long, right? Lacto, prolactin, obviously it's going to the mammary glands. You've heard of human growth hormone. Just think about stuff that grows. I mean, you could even put stuff that grows. I'd be fine with that. You gotta learn the word somato. But it's good to learn these words because these words end up in other words. It's your cheat code. Because once you learn the words and you're in nursing school or whatever you're going to, it's a massive help. It's a massive help. These aren't hard to me at all. Yeah, one, because I sit here year after year and blah, 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 talk about them. But, like, I've learned the language. So that's why it's not hard. All these words are familiar. So when I see a new word that's, like, really complicated and long, I'm relaxed. I'm like, yeah, that's just a bunch of little words that I knew from other things, and I just stick them together, and I don't forget it. If I told you the name whiteboard for the first time ever, you'd remember it because you know white and you know board. Just put the 2 words together. I can give you a bunch of new words. I say, okay, from now on, we're going to call this a class whiteboard. You're cool with that. I added the word class to it. You've heard of class. So that's all that is. So try to learn all these words. If you haven't taken MedTerm, try to learn the words because they're going to help you in the future. It's not for nothing. You're not just wasting study time. This is going to help you years down the road. Yeah, so what we're missing now, the hormone that is going to cause this to be released from the hypothalamus. Because in order to release any of these, we need a releasing hormone from the hypothalamus. So if you want to screenshot this, screenshot it. I'm about to erase this. So the releasing hormone, they're all going to end in RH. So I'm just going to fill in the RH right here. So what's the hormone that gets those cells going and causes this to be released? Well, this one we already know. TT. Gonad, gonad. So instead of writing gonad, we're just going to put GN for gonad. Big G, small n. So same name as the cell. The cell was called a gonadotrope. Here we just put gonad RH. This was called a corticotrope. It started with a C. So there's that one. Stands for corticotropin releasing hormone. Like just letters right now. This one, L would have been a very good guess, but it's not. And what would be your other letter that you would guess if L's not correct? P. And then we're on the last one. This one's a little different. GH, growth hormone releasing hormone. So those are your 5 releasing hormones that the These are the 5 releasing hormones that the hypothalamus makes. So once these are released, these can be made. These first 3 work on negative feedback. So that works on above my arm, negative feedback. These do not work on negative feedback. So when you want to stop prolactin, it doesn't just stop, because when are you going to say, when's the time to stop? You know, you're breastfeeding, so you can't just, you can't just say, oh, there's some good time. All right, it's been 8 months. So this one has an inhibiting hormone. So I'm going to call it PIH, prolactin inhibiting hormone. So there is a releasing hormone, there's also an inhibiting hormone, which is also called dopamine. In fact, dopamine is probably more common thing to say. So dopamine inhibits lactation. Dopamine can slow down the whole pregnancy thing. I mean, the birthing part of it. But anyway, prolactin releasing hormone, prolactin inhibiting hormone. That's it. You just switch it to an IH, and then you can already guess the other one. GH, IH, growth hormone, inhibiting hormone. Which has got another name, somatostatin. Somato meaning growth. Statin, stop. I just realized the computer getting in your way. So that is a lot of stuff there that I'm definitely going to ask a question about. I don't have a lot of questions because we're only meeting for 2 days. This is one of them. You have 2 of the big questions already. Mode of action of hormones, that's a big question. That was a big pain in the ass question. This is definitely a question. I'm not going to ask the whole chart, but I'm definitely going to ask the hormones. So I want you to list these hormones, and then I might ask you, what are the releasing hormones that cause their release? Or I might ask instead, what are the cells that make them? I'll ask like one or the other.
Are you talking about asking for the test or for the quiz?
Quiz. And it might show up on the test again. There's a lot of hormones here. I mean, definitely these 7. Like we're going to go into each one of these in some detail. It's a big question. It's a lot of stuff.
So this will be on the quiz for Wednesday?
For Wednesday. And their essay questions, short answer questions, whichever one of those 2 make you feel better. And you're saying, some of you are getting freaked out and saying, oh, that's like too much. But I'm telling you, list the hormones of the anterior pituitary, list the releasing hormones from the hypothalamus. Which ones work on negative feedback, or which ones don't work on negative feedback? That information is right here. Like you have the answer and you know what the question is. You're just listing it out. Or it might say instead, what are the cells that make them? And you would just list these, and then you'd list those cells. You know, thyrotroph. Yeah, it's words, like they're words to memorize. That's a pain in the ass, but you could have this down today. You just write. You're gonna have to write it out. Like write it out, and then go do something else, and come back and write it out without looking, and see if what you got right, and add to it. And before you know it, you'll have it. Do that today. Then tomorrow, wake up again and do it, because you're gonna forget some of this. Then by the end of tomorrow, it's like in your head forever. I'm making it all sound easier, but it's not. It's work. It's a lot of work, but you will see some of this stuff again. A lot of this stuff again, like outside of this class, you're going to see this again. So you're going to see all the glands. This is very common. If you work in a doctor's setting, doctor's office, hospital, you're going to see this for sure. It's a very common lab to do on people. But all this stuff also, adrenal hyperplasia, this is common. If you're working in whatever that's called, where you have babies, which I can't make my brain think right now, you're going to see dopamine, so you're going to see all that. Steroids, they give steroids all the time in hospitals. All right, anyway. Questions? So that's a lot. Yeah. Let's see what time it is.
10:02.
10:02?
Yeah.
Thank you. All right. Start talking about some of these by them. Oh, no, let's talk about the posterior. So this is the anterior pituitary. This one's much more difficult than the posterior. Posterior is much easier. So I'm going to erase all this. So the posterior pituitary doesn't make any hormones actually. It holds, it stores two hormones from the hypothalamus. That pen sucks. So the hypothalamus has made two hormones and it's storing it inside the posterior lobe. Where's that word? Here's the two hormones. Oxytocin, which sometimes they put oxy for oxytocin. I don't like to do that, but that's what it means. And then ADH. ADH stands for anti-diuretic hormone. There are no releasing hormones for this. All the anterior ones, the 7 we talked about, they each have releasing hormones. Here, no. The hypothalamus made it, stuck it in the posterior pituitary gland, and it just gets released when it's triggered by, there's like nerves. You got nerve endings all in there. And when those nerve endings get triggered, for example, when you're dehydrated, it triggers the nerves in the posterior gland, and it just causes it to be released. So the hypothalamus does not directly control the posterior lobe. It doesn't make it do anything. Let's do this one first. So this one is going to be oxytocin for uterine contractions. So we could give this to induce labor, right? You would see this. Uterine contractions and something called the letdown reflex. Meaning milk ejection, right? Prolactin is going to cause the milk to be made, but you got to put the milk into the duct, right? Prolactin is not enough. You need other hormones. It's synergistic. So that's what oxytocin does. Antidiuretic hormone. Another name for it is vaso or vasopressin. I would say that this is the more common word, even though it's, for me, that's more to write than ADH, but I know like in medical settings, they use vasopressin more. So to get into this, we need to talk about blood pressure for a second and water and stuff like that. So your body is set up to keep your blood pressure up. You need to keep blood pressure from going down, right? So our problem as society is that our blood pressure gets too high and we need to bring it down. But your body's not set up for that. Your body's set up for the opposite. Your body never imagined that McDonald's has that second car lane so that you can get in there and it's taking credit cards now. It didn't imagine that you'd be able to get 2,000 calories just in one drive-through trip. It thought that there's not going to be any food, and then you're going to have to chase around boars with a spear and kill them, and sometimes the boars are going to get you and you're going to bleed, so we need a way to get blood pressure up again. And so one of those ways is antidiuretic hormone. So blood pressure is directly related to the amount of blood that you have in the body. So if you have less blood, for example, you're bleeding, if you have less blood, your pressure goes down. If your pressure goes down, your cells aren't getting oxygen. You're screwed. You're going to go into shock. This is preventing shock. Blood volume. So blood pressure is related to blood volume. Blood volume is related to water. So when I drink a bottle of water, I literally have more blood than I did before I drank that bottle of water. So as I drink more water, my blood volume goes up, which keeps my blood pressure up. And then conversely, if I'm dehydrated, my blood volume goes down. I have a thicker blood with less water in it, less plasma. Right? So blood volume goes down, blood pressure goes down. So being dehydrated, one of the side effects is that your blood pressure goes down. So now you can see the anti-dehydration hormone, antidiuretic hormone. So why would you lose water? Well, you don't drink, you're not drinking enough water, you're drinking a bunch of coffee, alcohol, alcoholics, those are diuretics, alcohol, caffeine. People take laxatives. People are on water pills, diuretics. Some people do it because they want to lose some weight. So they're taking diuretics to lose a few pounds to get into like a dress, and then they're drinking Red Bulls, they're drinking alcohol. Sometimes they're mixing the alcohol with the Red Bull. Bad idea on top of bad idea. He looks nice. Another bad idea. Anyway, these are all related. So, how do we get blood pressure up? The first way is to stop losing water. The best way we have immediately to stop losing water is to stop peeing. So that's what it does. Oh, and so you would think, well, if I keep drinking bottles of water, isn't my blood pressure gonna just go way up too high? No, because your kidneys are filtering all that blood. And if you drink a lot of water, your kidneys, once the blood pressure gets up there where it should be, your kidneys will take that water and pee it out, right? It's why your urine's water colored when you drink a lot of water. And when you're dehydrated, your urine's nasty yellow, dark. It even gets like to a brown color. So that's why, it's partly because of ADH. So ADH tells the kidneys to hold on to the water. Don't make urine. Just make the bare minimum amount of urine, or like put the least amount of water that you need to put in there to get it out. So less urine. They call it vasopressin because it constricts blood vessels too. That's a quicker way to get blood pressure up. Take the blood vessel, squeeze it, pressure inside goes up. It'd be like squeezing, like you put the lid on the water bottle. You squeeze the water bottle. What's happening to the pressure inside? It's going up. Right? That's a quick way. That's a very fast way to make blood pressure go up. But another thing is that it tells your kidneys to hold on to the water. Bare minimum water here. So whenever your urine's dark yellow, you know that your body's releasing ADH. That's why it's like that. And you should drink some water. But if you're like in a hospital and someone's dehydrated, there's a few things that are going to happen. One, they're not going to pee, or they're peeing but the color. So you're looking at the color. You're literally looking at their pee color. And then what do you think was going to happen to your heart rate as your blood pressure goes down? You got two choices. Heart rate goes up or heart rate goes down. So how would you compensate? You can just think it to yourself. But your heart rate's gonna go up. Because you have to try to compensate for the fact that your blood pressure's down. So you're gonna try to pump it around faster, like go harder. And so your heart rate's gonna be up. Heart rate's gonna be elevated. Urine's gonna be dark. Blood pressure, I mean, this is coming later, but your blood pressure's not going to be normal. Like a normal blood pressure, just to make up a number, people say 120 over 80, right? So there's 40. I'm not testing you on this, but I mean, there's 40 difference between 120 over 80. I'm going to see lower numbers. So just to make up something, like 90 over 70, right? So not only are the numbers lower, but the numbers are closer together. That would be a good sign of like, I don't know. Whatever, that's all for you to learn. Just trying to make it fit in with life. But that's what antidiuretic hormone does. It controls the amount of water, controls blood volume. I mean, by controlling water, you control blood volume, and then therefore you control blood pressure. There is a third thing that it does. It's not like a big deal. It reduces the amount of sweat that you put out. That's a gamble, because if it's hot outside, you don't want to reduce the amount of sweat. That's a last-ditch effort. It's like, well, I'm going to die one way or the other, so I'm just going to go, because once you don't make sweat, you really overheat. But this, you probably had this happen. Both of these things happen in your life many times. Often we don't notice it. So we call this like, these are compensatory mechanisms. This is how you don't go into shock. All right, so that's the posterior. That's all of it. So there's no types of cells. You don't have to learn types of cells. You don't have to learn releasing hormones. Target cells, no, but I mean, you know, I mean, where's this going? It's already telling you where it's going. And then this is going to your kidneys. Your kidneys are the ones that determine how much water goes into your urine. So, questions? Let's recap. Let me think about like test questions. One, we know the mode of action of hormones. Two, the anterior hormones. Three, how does ADH work? I'm trying to get to 5. 4, hormone interactions. So hormone interactions were primitive, synergistic, antagonistic. I'll go over them in a second. 5, what else? The let me erase this. I'm going to give you one more thing. So I'm going to have a total of six things, and I'm going to ask 5 of them. So you're going to know, and there's nothing. Honestly, you're not getting anything special. You're not. I mean, you could say, well, he's giving us the questions beforehand. I am, but you still got to learn everything. Right? But it's better than having to learn everything, and then I ask you some multiple choice question that is worded way different from how I speak, and then 2 of the answers are bogus, but 2 of the answers are like super close, right? And you're like, man, is it C or B? C or B? And then you're like, C. Right? We think that multiple choice is easy, but if you don't study, multiple choice is worse than the way I ask you questions. Grades go down when I go to multiple choice. Grades go up when I go to this way. Because you know what's going to happen, and you know you have to study. You're not going to be able to walk in and just pull it off. It doesn't work. So there's one more thing I want to talk about, and that is human growth hormone. So I'm going to put that as number 6. I'm going to talk about what it does, how it works. So, under the influence of human growth hormone, your body is going to make these, another hormone, or like these proteins, and they're called insulin-like growth factors. So, these two are related. IGF. Insulin-like, so I'm actually going to write it out. And you're looking at it, you're like, man, it's got the word insulin in it. So is insulin also like tied into all of this? Yeah, it is, but we're not talking about that. But like lots of hormones are all interacting with each other, right? And lots of hormones do one thing. This is about growth, right? Human growth hormone, so it's about human growth. What about thyroid? Yeah, that's involved too, right? When you're growing, you also need to have more metabolism. Think about someone that's going through puberty, right? So they're growing, growth spurt, they need their metabolism to go up. So it's not only this hormone, there's other hormones that are going to work with it to help you grow. But right now we're talking just about this. So human growth hormone is related to these other hormones called insulin-like growth factors. And so insulin-like growth factors are going to go to different cells like muscle and your bone, things like that. And they're going to cause a few things to happen. One, in no particular order, lipolysis, lipolysis. Lysis means to break or to burst. Lipo, we're talking about fat. So breaking up fat. We're breaking up fat stores. Under the influence of a lot of HGH, people should have their percent body fat start to decline because you're breaking up that fat and you're using it as energy. In fact, in little kids, sometimes before they go into puberty, you'll notice that they'll put on a few extra pounds. So you know that like the growth spurt is going to come because that's like your body's kind of putting on a little extra weight, but it's going to use that energy when the growth spurt hits. But anyway, lipolysis, because we're breaking up fat because we want to make ATP. If you should remember, but ATP is our energy currency. Fat is energy, sugar is energy, but we have to convert that into a usable form of energy. So fat and sugar is like Mexican pesos and Canadian dollars, right? It's money, we just can't use it. We got to convert that into American dollars. That's the ATP. So that's one thing that it does too. There's different ways I can say this. I'm going to say glycogen breakdown. And then I'll explain what that means. I'll let you write it first. I should be done by 10:30. So glycogen breakdown. We're going to talk about this again, probably next class. Glucose is your blood sugar. So when you want to lower your blood sugar, like when insulin's made, you're going to store that blood sugar as glycogen. So you're going to store that sugar in your liver and muscles. So that's what insulin does. Insulin, I mean, you know that insulin lowers blood sugar. How though? Because it takes it and stores it in your liver and muscles. And then later on, when you need the glucose in your blood, you break the glycogen up and you put that sugar back in your blood. So you're always going back and forth all day. You're storing glycogen and you're breaking up glycogen. I ate breakfast, thinking if I ate breakfast. I ate breakfast. My body's breaking all that down right now, and my blood sugar is starting to go up. So my blood sugar is going up. I'm going to release insulin, and I'm going to store that sugar in my liver and muscles. In a few hours, I'm not going to eat anything else. So in a few hours, my blood sugar is going to start to drop down. Then I'm going to break the glycogen up. Here, it's different. If I were going through a growth spurt, I wouldn't wait. I'd break the glycogen up. Because I need that glycogen now. I can't wait until 2 o'clock to break it up. I want it this morning because I have to grow. For me, no, I'm 50. I'm shrinking. So I can hold on to this. I'll keep this until the afternoon. Then I'll put it back into my blood. But people with a lot of growth hormone in them, no, they're breaking it up. So obviously they're going to be hungry because they're breaking up their fat, they're breaking up their sugar stores. They're going to want to eat a lot more. But both of that is for making more ATP. That's our energy source. Now we have the third thing that we eat in our food. Because remember, there's 3 things in our food. There's carbohydrates, there's lipids, and then there's proteins. That's what we eat when we eat food. I had hash browns today, a hash brown, which I shouldn't have ate. But they put it in the bag. I didn't even ask for it. I think they just give out, that's like extra, those hash browns. So I ate the hash brown. That was all sugar and fat, oil. Because the oil was just all over my hands. So that was fat and that was sugar. Then I had a Egg McMuffin. The egg was the protein, right? The muffin part was sugar, was carbohydrates. The cheese was mostly fat. The egg was protein. So there's 3 things you get when you eat food, right? So we've talked about these 2. What happens to the proteins? I wrote this wrong. You're going to increase the amount of proteins you use. There. Because I want to, when you're growing, you have to make more bone, you have to make more muscle, you have to make more anything. And the answer to all of that is always proteins. It's all made out of proteins. So if I want to make more of something, I need proteins. So whatever proteins you're going to eat in your food, you're going to use a lot more. So someone that's like 15 is using a lot more of that egg than I'm using. I'm going to use some of it, not that much. I still got to grow stuff. Thankfully, I'm still making some hair, and I can still make some skin, so stuff like that. But you know, think about a 15-year-old. They're making a bunch of stuff, so they're really taking more protein out of their food than someone like me, because they got to grow stuff. So they're taking more protein from their food, and they're using it more. So that's what growth is. So to grow, you need protein. People in hospitals that are in there a long time and they're on like special diets like TPNs or whatever, that's always one of the issues. They have to repair, you have to repair a broken ankle. You have to, whatever you have to repair, you've got something and you have to repair yourself. You need proteins. That's always an issue for people. But that's not enough. You need proteins, but you need the energy. Keep slipping off. You need the energy to use the proteins. How do I take the protein from my Egg McMuffin and convert that into muscle? Right? I have the protein, that's in the egg. How do I but now I've got to get energy so that I can turn that egg into leg muscle or whatever, right? So that's this. So this is your answer to number 6. How does HGH, human growth hormone, work? You're gonna find other hormones next class that do the same thing as HGH, just for different reasons. For example, steroids. Steroids do the exact same thing, just different reason. With steroids, you're trying to fix a broken ankle. With this, you're trying to grow. Different intentions. Same thing though. So, mode of action of hormones. Lipid soluble, that was the easier one. Remember, it went in and changed the DNA, genetic expression. Water soluble, that was the pain in the ass one with that whole thing, G protein, cyclic AMP, all of that. That's a pain in the ass. So if you didn't work on it over the weekend, which you should have, work on it now, today. The interior hormones, we did that today. That was that list. I'm going to ask you, list the anterior hormones, the hormones of the anterior pituitary, and say and list the releasing hormones. Or I could say list the target cells, or I could say list the cells that make them. Those are 2 big questions. What's the function of antidiuretic hormone? Don't just say less P. I'm going to say explain, less P. That's 2 words, that's not an explanation. So you talk about conserving water because that's related to blood volume, like how much blood you have, and that's related to your pressure. And if you want to throw in the fact that it constricts your blood vessels, that's even better. But that's what it does. I mean, if I were to just see you on the street and be like, hey, what does ADH do, right? And just that way, you don't need fancy words, just tell me what it does, like you would just tell me, or just like you would tell your friend. Not that you would tell your friend, but hormone interactions. Synergistic, they work together. Antagonistic, they work against each other. Permissive, one hormone needs permission of the other. You don't have to use my definitions for anything. If you get something from the book, if you get something from a Khan Academy video or something, that's fine, right? If you know it, you know it. I don't care. You don't have to do anything that as long as you know it, it's fine. Upregulate, downregulate, we're talking about receptors. Your cells can have more receptors or less. Just depends on how much hormone's available. If there's not enough, you're going to make more receptors. The morning after pill is an example of downregulation. The morning after pill goes to the target cells for progesterone and it downregulates it. It goes to the cell and now you have, way fewer receptors. So you don't actually take in as much progesterone anymore. So the egg cannot stick to the uterus. But anyway, that's an example though, like RU46. I haven't taken it in weeks. Human growth hormone, that's the last one. In a narrative form would be nice. I would like you to explain it. So just say that, what's going on. Think about what's happening with your fat stores, what's happening with your sugar stores, and what's happening with the protein that you eat. Because if you were to do this, lipolysis dash ATP, okay, that tells me that you memorized this. But you don't know how do I know you know what that means, right? There's a good chance for a lot of you don't. You just memorize this. What is lipolysis? Oh, breaking up fat. That's it. That's all I want. What's ATP? That's your energy. That's how energy is in your body. If you want to grow hair, if you want to make sweat, if you want to break down an egg big muffin, how do you do it? The answer is ATP. You need energy to do all these things. I'd like you to know what that is. I know I just wrote that, but I'd like you to be able to explain what does that mean. But those are your questions. That's the quiz. I'll pick 5 of these. You know what I'm going to ask you, no surprises. Just write it down. You can take all this, write it down today, write out your answers today. If you're feeling nervous, like maybe I didn't get one of these questions, email it over to me. Hey, did I write this down right? And I'll even fix it for you. So the only reason that you're not going to get 100 on this is because you didn't spend time on it. So you got to work on this stuff every day. You can't wait until Tuesday night at 2 o'clock in the morning and you didn't sleep well again and you're just going to try to pull it off. It doesn't work. It never works. So just study and you're going to get it. I know it's a lot more studying than maybe you had last semester, and I know the questions aren't like the type of questions you'd like, but there they are. Does anyone have any questions? Those are like a short class, a shorter class today. After you, so Wednesday I'm gonna push ahead and give you even a little more information. So I'm gonna finish this chapter probably on Wednesday. So I haven't thought of it yet, like how we're gonna do the test, how you're gonna come in for the test, and then how we're gonna do a lecture on top of it. I don't know. I'll send you guys a text, and I'll make an announcement, tell you whatever I'm gonna do about that. I might just make the videos and make it asynchronous. So, I don't know. I might add an optional little study session on Friday for people that feel like it. It's definitely not something you have to come to. I don't know. I haven't figured it out yet, so I'll send you a message today. So I'm going to stop recording. I'm going to post this. I'll post this in about an hour or so. It takes a while for me to get it uploaded.